Hello, everyone, and welcome back to our final CoffeeShop Astrophysics talk of this semester. It's great to see you all. We'll be back next semester. It's okay. All right. If you have an idea for a future CoffeeShop talk, you can feel free to go to our website, and we have a nice little form you can fill out. You can also just come up to us and talk to us after the talk. Who are we? We're a group of graduate students and postdocs from the University of Wisconsin-Milwaukee, and we all work in the Center for Gravitation Cosmology and Astrophysics. Today, your speakers are myself, Amanda Baylor, and later Ronan Humphrey will be speaking. So to preface this talk, I need to tell a little story. So one of our coffee shop members had a family member visiting them over the summer, and that family member came to our department happy hour, and they sat down with a bunch of astronomers from the department, and they said, "Hey, whatever happened to Pluto?" And everybody just kind of sat there and was like, well, nothing. I mean, it's still out there in space, orbiting the sun, doing its thing. But what has changed is our relationship with Pluto. You know, it went from being not a planet to a planet. What exactly happened in between, and what's its status now? Well, we're going to dive deep into this important question and start from the very beginning. And that is the search for planet X. So back in the late 1800s, astronomers noticed that the Neptunes of Uranus and Neptune, the orbits of Uranus and Neptune were being perturbed. And a perturbation is just a small deviation from the normal orbit that they had. So they thought that there was another planet past Neptune which was actually affecting the orbits of Uranus and Neptune. So Percival Lowell was a wealthy businessman from Boston, and he happened to really like astronomy, so he taught himself astronomy, and then he built his own observatory in Flagstaff, Arizona. And he began searching for planet X in 1906. Pictured here is Percival and his telescope that he used to stare at the sky all night looking for this mysterious planet X. Now, he actually died in 1916, not knowing he accidentally captured two faint images of Pluto in 1915. But Percival's widow, Constance Lowell, enters a 10-year legal battle with the observatory. So the search for planet X does not actually resume until 1929. Now, you can actually go visit the Lowell Observatory. I've been there. It's a fantastic place if you're ever in Arizona. And you can go see the telescope that he actually used. So the search begins again. A new 13-inch telescope is built, and this telescope is a refracting telescope, which I include here in this diagram. It's named 13-inch because that's the diameter of the lens that they're using, and light comes in, gets focused by the lens, and then into the eyepiece or a camera if you have one at the bottom. So they hire 23-year-old astronomer Clyde Tombaugh. Now, Tombaugh doesn't have any formal college education at all. He actually taught himself to build telescopes and operate them, and he sent the Lowell Observatory some really nice pictures that he drew by hand of Mars and Jupiter and all of their features. So he ended up getting hired by the observatory to locate this planet X. Now, here's the 13-inch telescope. $10,000 was actually donated to the observatory in 1928 by Percival's brother Lawrence to build this telescope. That's equivalent to about $180,000 today. And that telescope is there at the Lowell Observatory. So, on clear moonless nights, Tombaugh would take pictures of select areas of the sky. It had to be moonless because the moon is extremely bright and interferes with a lot of astronomical observations. So he would take an image of the same area of the sky in order to compare them later. So he would focus light on a glass pane, which is about 14 inches wide by 17 inches long, and you can see him holding it here. And that glass pane is covered in photosensitive chemicals, and then it's put at the bottom of the telescope here in this little slot. And light will get absorbed by the photosensitive chemicals and create the images that I'll show you later. So it required an hour of exposure time per image, and he also was only able to take pictures of the sky about the size of your fist if you held it at arm's length. So in order to capture the whole sky, he had to take tons of pictures, and it took a lot of time. Now, if you have a keen eye, you'll notice that the telescope has a boxing glove on it, and that's because this telescope likes to fight back. I've actually been here in person and asked about this boxing glove, and it's because this telescope is operated by hand. It doesn't have any computers on it. So in order to move it around, you have to grab this metal rod sticking out, and you can imagine at nighttime when you can't see anything in the telescope dome, if this telescope whacks you, you're going to get a pretty nasty concussion. So they put a boxing glove on it in order to tell where the telescope was at night. Okay, so Tombaugh would compare images of the same exact area of the sky taken a few nights apart. And he used this special apparatus called a blink comparator. So he'd put 2 images in there and look through the slot, and then allowed him to rapidly blink between images. Now, we can actually do this with a computer today. You just hit the arrow keys on your computer and go back and forth between pictures, but they didn't have that back then in the 1920s, 30s. So he used this, and he would spend all of his days just staring at pictures that he took the night before. And it helps differentiate from stars from planets, asteroids, and comets. So stars essentially have a fixed background in the sky. They don't move a lot between nights. But things like planets, asteroids, and comets move really, really fast. So you're going to be able to identify things that are changing between each night. So on February 18th, 1930, Tombaugh discovers a candidate object. So I'm going to show you the exact 2 pictures that he compared, and let's see if you can spot Pluto. So there's a lot of things going on. You might think that. Save that question for later. But if you look actually here, do you see a little object moving just between those 2 stars in the middle? Maybe it'll help if I circled it. So it's here, and then it moves past these 2 stars in the middle, and it's over here now. So yeah. Tombaugh found this right away because he'd been staring at so many of these images every single night. He was like, oh my gosh. Then, he goes, I found your planet X. And of course, astronomers have a really hard time naming things. So what do we call it? So we got this new planet, and upon announcement of its discovery, the observatory received over 1,000 suggestions for names. But one of them came from 11-year-old Venetia Burney, and she writes proposing Pluto. Now, she was really into mythology, and Pluto is the Roman god of the underworld, pictured here in a statue form with his dog Cerberus. So she proposed this, arguing that both the planet and the god can render themselves invisible, and they live in dark, gloomy places. So it just made sense. So Pluto was officially adopted and approved and published on May 1st, 1930. And of course, everybody wants to name their kids Pluto now because we got this new planet. So in 1930, Percival was also suggested as a name for the planet. However, they wanted to stick with the mythology theme that was kind of running with all the planets. So Percival Lowell was instead honored through the planet's symbol, which is a P and an L. And then in 1931, Walt Disney debuts this character named Pluto. And then in 1940, Edmund Hamilton refers to Pluto's moons Charon, Styx, and Cerberus in his science fiction novel Calling Captain Future. But what's really interesting about this is none of Pluto's moons had been discovered yet. They didn't even know Pluto had moons. So this is just complete coincidence that he happened to name them the exact names that we choose later. And then Glenn Seaborg discovers a new element, naming it plutonium in 1941, following the naming convention that we have where we discover a planet, discover an element, name the element after the last planet. We have Neptunium and uranium for that reason. So Pluto has a really interesting orbit. It ranges between 30 and 49 AU, and an AU is an astronomical unit, which is the distance from the Earth to the Sun. So 30 to 49 times that is where Pluto orbits. That's about 2.8 to 4.6 billion miles away. It's also highly elliptical in shape, and all the other planets have really nice circular orbits, as you can see in this diagram. But Pluto's crazy. He follows this oval-shaped orbit and goes all over the place. It's also inclined to 17 degrees relative to this thing called the ecliptic. And the ecliptic is where all of the planets generally orbit in this flat plane around the sun. But Pluto, he has his own way of going around. So Pluto actually comes closer to the sun than Neptune at one point in its orbit, making it the 8th planet at a certain point in time. So in 1979, you can actually follow the dates here. In 1979, he starts coming into Neptune's orbit and becomes the 8th planet. And then in 1999, he left that orbit and became the 9th planet again. So this won't happen for another 200 years, but it's very interesting how they change positions. But it's also in orbital resonance with Neptune, so it's never going to actually collide with Neptune if you were worried about that. So for every 2 orbits Pluto completes, Neptune completes exactly 3. So they're in this highly synchronized orbit. And then also it orbits really far above Neptune at this point, so it'll never ever come close enough to collide. 1 Pluto day is equal to 6.4 Earth days, and that number will be important later. And 1 Pluto year is equal to 248 Earth years, which means in 2178, Pluto will complete its first orbit since its discovery. How exciting. Not too much longer. So Pluto's home, where does he live out in space? Well, he lives in this disc-shaped region called the Kuiper Belt, and that's defined as a region from 30 to 50 AU in space. And then this disc-shaped region is actually filled with a lot of small bodies, and they're mostly icy, and they might have life-supporting elements, but that is yet to be studied right now. So Pluto is actually the largest known object in the Kuiper Belt, even still today. And then we discover Pluto's moon, Charon. So in 1978, these highly magnified images of Pluto were taken at the United States Naval Observatory in Flagstaff Station. That's 6 miles from where Pluto was discovered. So they were actually not looking for a moon. They just wanted to take really good pictures of Pluto. And they saw this weird bulge coming out. Now, these were taken with a 61-inch telescope. Compare that to the 13-inch telescope I talked about earlier. So astronomer James Christie notices this, and the bulge appears periodically, but then goes away again. And then they notice that this is a moon that Pluto has. So the moon is eclipsing Pluto, and then it goes away again and comes back into the picture. So they named this moon Charon, after the ferryman who carried souls across the underworld river in mythology. And it's also to honor his wife, Charlene. So he wanted to name the moon after his wife, but they said, no, you got to stick to mythology. So he said, well, her nickname is Charon is close enough. Yes. Yeah. So these are actually how pictures come out when you take them with telescopes. They don't actually look that nice. So these are just the light collected, but it's an inverted color format. So the other ones were like black background on white. These are black on a white background. Yeah, so these are all just like stars and things in the background, but they had to take really, really long exposures in order to look at Pluto because he's really far away. So yeah, good question. Okay, so Charon is actually the largest moon relative to its planet size in the solar system. And its diameter is just over half of that of Pluto. And it orbits Pluto every 6.4 Earth days. So the exact amount of time it takes for Pluto to make one rotation is the amount of time it takes Charon to go one revolution around Pluto. But what's even more interesting is they're in this tidally locked binary system. So tidal locking, we've talked about before with our own moon. Only one side of the moon faces us at all times. Charon and Pluto are essentially just staring at each other. They're both tidally locked to each other, and they always see the same face of each other. But even more interesting than that, they're in a binary system, which is totally different than any other moon-planet system we've seen in the solar system. So compare that to our own Earth-Moon system. The point at which Earth and Moon orbit together is inside of Earth. So Earth doesn't actually move. It rotates on its axis, but it doesn't do this weird thing that Pluto's doing, where it's orbiting around a different center of mass that's not inside of itself. So they're essentially in this binary system. So how massive is Pluto? Well, there was a really long dispute about it. Percival Lowell ended up thinking that it was about 7 Earths large, based on observations that had been done before of the perturbations in Uranus and Neptune's orbits. And then in 1931, after they discovered it, they said, oh no, it can't be more than like 1 times the size of Earth. Then more calculations are performed in 1948, which said that it can't be more than 10% the mass of Earth. And then in 1976, Pluto's albedo is measured, which is shown down here compared to all the other planets in our own moon. And Pluto actually has a really high albedo, which means it reflects a lot of light. So they found that it is exceptionally luminous for its size. The larger this fraction, where 1 being the most, 0 being the least, means the more light that it reflects. So Venus is the highest albedo, but Pluto is actually pretty far up there. So they said, you know what, it can't be more than like 1/100th the size of Earth. It's got to be smaller. Then, after the discovery of Charon in 1978, they made the first official measurement of Pluto's mass, and it came out to be a really, really small fraction of the Earth's mass, which is a lot closer to what we know it to be today. Now, Pluto has some other characteristics. Its diameter is about 1,500 miles, which is about half the size of the United States. It has the surface area that's equal to about Russia or Antarctica, so it's a very, very small planet. And then Charon is shown beside it, so both of them cover the length of the United States together. And spectroscopy was eventually performed to measure Pluto's spectrum. And spectroscopy is essentially seeing how light and matter interact with each other, and that can tell us about the composition of Pluto and its surface, its atmosphere, etc. So they found that the surface is icy rather than rocky. It's 98% nitrogen ice, which is just solid nitrogen. So it means it's really, really cold and really, really bright. They also found traces of methane and carbon dioxide. And then in 1980, the Hubble Space Telescope captures these images of Pluto and Charon together, and here is a 360-degree view of those images that it took of Pluto. So, not super nice pictures, but it's really cool that these were the first ones officially taken by a space probe. So then there were some early mission proposals. People were really interested in getting to Pluto. So in 1964, Gary Flanders proposes this grand tour, and he essentially proposed that we could use the gravity assist from a planet alignment that was going to happen in the 1970s. So we could take the probe, throw it out into space. It could utilize the gravity of the planets in order to sort of slingshot itself farther into space. And if you remember from our Voyager talk, which if you haven't seen, you can go to our YouTube channel and watch it. It's very good. They took the probe and they used the gravity to throw it out farther. But it wasn't used necessarily for a Pluto mission, it was just used for Voyager. So Voyager 1 had the opportunity to visit Pluto, but they said, you know what, Pluto's not as interesting as Saturn's moon Titan, so we're gonna go see Titan instead. And that slingshotted the Voyager 1 space probe out of space, and it wasn't able to visit Pluto. It's rejected, sort of. They used the idea, but they didn't visit Pluto. So then Fire and Isis proposed. This is really interesting because they proposed going around the sun. So it was really a time where they wanted to know more about the sun as well in the 1980s. So they proposed, why don't we just send a solar probe out to the sun, and then it can go and visit Pluto after it's done. So fire and ice, because Pluto's really cold. So they were like, no, that's dumb. We're not going to do that. And then finally, in 1989, the Pluto Underground Alliance is formed. And this was an alliance by Alan Stern and other scientists to sort of generate excitement about Pluto, because they were like, all right, it's about time we had a mission to Pluto. We've been talking about it for like, I don't know, 20 years by this point. So they wanted to generate some commotion and draw some diagrams for a potential space probe and get really serious about it. So the Pluto 350, which is shown here, is proposed in 1990. And it's 350 because its weight is 350 kilograms. It's about 700 pounds. And the point of the space probe was to be really, really small so that it can make the journey out to Pluto really fast. Compare this weight to the Voyager space probes, which are about 1,800 pounds. So it was a really light spacecraft. And then it cost $543 million, and it was built to withstand those really cold temperatures out where Pluto is. Now, this idea was rejected, again. They said, this is too high risk, and the spacecraft is too small, it'll never make it. So then, 1991 comes around, and the US Postal Service releases this really nice set of stamps. You know, it's all the planets and our own moon with the space probe which explored it. Except there's one odd one out. It's Pluto. So yeah, there's no space probe that went to Pluto at this point. It's not yet explored. And it became sort of embarrassing. They were like, well, this is just work left unfinished. This is a job we didn't complete, a goal we never reached. So the stamp, it was actually ended up being used in proposals and presentations for another mission to Pluto. And in 1992, Jet Propulsion Laboratory scientist Robert Stale calls Clyde Tombaugh the original discoverer of Pluto, and he says to him, you know, can I go visit your planet? So Tombaugh recalls telling Stale, I told him he was welcome to it, though he's got to go on one long, cold trip. So this call eventually led to the launch of the New Horizons space probe, which would go visit Pluto. I'm going to hand it over to Ronan, who's going to talk about that. Thank you.
All right, so Robert Stahl did form a team that would eventually become the New Horizons team in December of 2000s. This was at the Johns Hopkins University Applied Physics Laboratory, or APL. The person in charge, the principal investigator, was Alan Stern, who Amanda told us about in the Pluto Underground program. And this is our mascot, Gabe, reminding me to tell you that we do have these exact stickers down at our little merch table, so feel free to grab one of those on your way out. So the mission objectives for New Horizons were to look really closely at Pluto and Charon. So they wanted to look at the surface composition, find out what it's made of, characterize the geology, things like mountains, crevices, and also the morphology, the general shape of the planet. And they wanted to characterize this nitrogen atmosphere that Pluto has, because that's really interesting. It's similar to what we have here on Earth. And then look for an atmosphere around Charon, because one had not been detected yet. They also wanted to map the exact surface temperatures. We have pretty good guesses. We know it's quite cold, but they want to get a better number. And then look for rings and other satellites, other little moons around Pluto, and then go on to the rest of the Kuiper Belt and look at other Kuiper Belt objects. So things like these are very expensive and they need funding. In November of 2001, New Horizons was selected for funding as part of NASA's New Frontiers program, which is basically a competition that NASA held that scientists could submit proposals to for potential NASA funding. So it was selected for this, but it did not actually make it onto the 2003 budget for NASA, effectively killing the program. However, the next year, in 2002, the Planetary Science Decadal Survey for 2003 to 2013 came out. This is basically a wish list compiled by the United States National Research Council that says what scientists in America want to see done in the next decade. New Horizons ended up topping the list of projects in its category, beating out missions to the Moon, Venus, and Jupiter. So this is a little screenshot from it. It's called here the Kuiper Belt Pluto Explorer, and it's described as a flyby mission of several Kuiper Belt objects, including Pluto and Charon, to discover their physical nature and understand their endowment of volatiles. So endowment of volatiles just means what elements are on there: hydrogen, nitrogen, carbon, a lot of stuff that we associate with supporting life. You can see it is number 1 here. This is in order of importance. The second mission here is to the Moon, and then Jupiter, and then Venus, and then a comet. So following the publication of this, NASA administration said, well, I won't fight that. So it was eventually funded, and then launch was planned for January of 2006 with an expected arrival date at Pluto somewhere in 2015. So before it gets out there, we want to know what it's going to encounter. So using the Hubble Space Telescope, a team of scientists called the Pluto Companion Search Team discovered these 2 moons, Nix and Hydra. They were initially named S2005P1. S is for satellite, so something that orbits another body. 2005, the year they were found. P for Pluto, and then 1 and 2, just the order they were found in, on May 15th and 18th of 2005. They later got their kind of real names of Hydra and Nix, which are both mythological names, of course. Hydra is a 9-headed serpent in Greek mythology, and Nix is the Greek goddess of darkness and night and the mother of Charon, so very appropriate. Additionally, the initials Nix and Hydra are the same as New Horizons. So January 19th of 2006, New Horizons launched from Cape Canaveral in Florida. You can see on this little video, it swings by Jupiter, so it gets a gravity assist, similar to what Amanda was telling us was eventually used for the Voyager missions. But that's the only gravity assist it gets, and then it's on this really straight trajectory out to Pluto. And you'll see Pluto's that purple line. It'll swing very, very close to it and get some lovely photos for us. And then once it passes Pluto, it's going to go deeper into the Kuiper Belt, take some more pictures, and then eventually leave our solar system, just like Voyager 1 and 2 have. So we're not just going to visit, we want to do some good science out there. So New Horizons is not going to land on Pluto, it's just going to fly past it, so we can only look at the light coming off of Pluto. So humans only see in visible light. You've probably heard this before if you've come to one of our talks. We characterize light by its wavelength, which is the distance between peak to peak and trough to trough. So New Horizons will look across many different wavelengths in infrared, in ultraviolet. There are some radio experiments on there. And there's also a lot of spectrometers, which Amanda told us about a little bit earlier. Will tell us more about the matter on Pluto and how it interacts with the light. New Horizons also has some other cargo. There are 434,738 names on a CD. So NASA held this initiative. You can send your name to Pluto. So people submitted lots of names. There's also the Florida State Quarter, which if you remember from the early 2000s, were a bunch of quarters for each state. And Florida's commemorated a bunch of space travel stuff, and also New Horizons launched from Florida, so it's very appropriate. There's also a small canister pictured on the left here of Clyde Tombaugh's ashes with a lovely inscription. A piece of Spaceship One, which is the first privately funded spaceship to be created, and that Pluto Not Yet Explored stamp. So that stamp would eventually hold the Guinness World Record for the farthest traveling stamp. So what else is out there? What else is New Horizons going to see? Well, into the later 20th century, we're discovering lots of other trans-Neptunian objects. So these are objects near or past Neptune's orbit. Most of these are in the Kuiper Belt, so we call them Kuiper Belt objects. And these Kuiper Belt objects are split into 2 kinds, both characterized by their orbit. So classical Kuiper Belt objects have circular orbits around the sun that are largely unperturbed by Neptune. And then there are lots of resonant objects. So these are, again, broken up into 2 kinds. So there are Plutinos, which have the same resonance as Pluto, that 2-3 ratio. For every 3 times Neptune goes around, these objects go around twice. And then there are also Teutinos, which have a 1-2 resonance with Neptune. So as we're discovering more of these, it brings us back to a question that really started in 1801 with the discovery of Ceres, which is pictured at the top here. So in 1801, astronomers discovered Ceres and took it to be a missing planet between Mars and Jupiter in what we now call the asteroid belt. But as telescopes got better, as more people are looking, they start discovering more and more of these planets. And by 1851, there were 23 of them, including the 8 planets they already knew about: Mercury, Venus, Earth, Mars, etc. So they start calling these other things asteroids, and that stuck for a while. And then in the 1990s, especially with more space probes, we're discovering more Kuiper Belt objects. And some scientists kind of stop referring to Pluto as a planet, and some planetariums even start removing it from their education materials when they model the solar system. And then in the early 2000s, we discover several very large Kuiper Belt objects, including Haumea in 2004, Eris in 2005, and Makemake in 2005. And these are very interesting because they're not much smaller than Pluto. This is close to scale images with our moon on the left, then Pluto, Eris, Haumea, Makemake, and Ceres. If you look particularly at Pluto and Eris, they are nearly the same size. Pluto is a little bit larger, but Eris is actually more massive. So this brings scientists to question, well, are all of these planets, or maybe is Pluto not a planet? This is particularly appropriate as Eris is the goddess of discord, and it caused quite a lot. So this issue was brought to the International Astronomical Union's General Assembly in August of 2006. They went through a few drafts together and then finalized a definition for a planet that I will read here. A planet is a celestial body that A, is in orbit around the sun, B, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium that is a nearly round shape. I will go into more of that later. And C, has cleared the neighborhood around its orbit. So this is not a multiple choice. A planet needs to meet all 3 of these in order to be a planet. And it's this last one that kind of kills Pluto. So this is the nail in the coffin. And the IAU explicitly states that planets that meet criteria A and B but not C are called dwarf planets. So all of the planets I showed before are now dwarf planets because they have not cleared their orbit. They're all in the Kuiper Belt, which is a very busy area. This caused a little bit of scientific outrage. Alan Stern, who you remember is in charge of New Horizons, argued that Earth, Mars, Jupiter, and Neptune have also not cleared their orbit. Here on Earth, we orbit around the sun with about 10,000 near-Earth asteroids. There's a bunch of stuff in our orbit. Jupiter has 100,000 Trojan asteroids, which are pictured in green here. So that outer ring is Jupiter's orbit. I realize it's a little bit small. And then all of those green dots are Trojan asteroids that go around with Jupiter. And Alan Stern is quoted as saying, if Neptune had cleared its zone, Pluto wouldn't be there, which is, of course, because Pluto crosses Neptune's orbit. The counter-argument for this is that all of these other planets are gravitationally dominant within their orbits. So here on Earth, these near-Earth asteroids orbit around with us, and we're actually slowly accumulating them on the scale of about a million years. And then Jupiter's Trojan asteroids, you can see quite clearly, they go around with Jupiter. They're not on their own orbits. They are going around the sun based on Jupiter's gravity. So we would still say that Jupiter is gravitationally dominant. And as for Neptune and Pluto, as we've discussed at length in this talk, they are in that 2-3 resonance. And this resonance is dictated by Neptune's gravity, not by Pluto's. There's another point of scientific outrage regarding the hydrostatic equilibrium point, point B. So I'll go into a little bit more of that. To rephrase, a planet needs to have sufficient mass to be in hydrostatic equilibrium. So what this means is that the gravity pushing down on the planet, the self-gravity, equals the internal pressure, the forces holding the planet up, basically. So when these are exactly matched in all directions, you get a sphere. So if you compare a planet like Venus here up top to an asteroid like Vesta here on the bottom, you can pretty clearly see the difference. Venus is round, the asteroid is not. However, when I showed the definition, I left out this little footnote. So there's a footnote right after planet that leads to the statement that the 8 planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But there's something slightly interesting about Mercury. Very detailed calculations that I do not have time to go into have shown that it is not actually in hydrostatic equilibrium. It remains a planet, of course, as it's explicitly included in the definition of a planet. So there was also a fair deal of public outrage. People were really upset by this. Pluto has been a planet for 75 years and they want it to continue to be one. It's in all the textbooks, it's in all the planetariums. Why should it change now? The same year as the IAU decision, the American Dialect Society voted Plutoed as the word of the year, meaning to demote or devalue someone or something. The California State Assembly presented quite a scathing resolution. It was very comedic and presented slightly facetiously, but it reads that the mean-spirited International Astronomical Union decided on August 24th, 2006 to disrespect Pluto by stripping Pluto of its planetary status and reclassifying it as a lowly dwarf planet. These are all public record. I recommend going to read them. It's very fun. Somewhat more seriously, Clyde Tombaugh, who discovered Pluto, spent significant time in New Mexico. He had an appointment at New Mexico State University for almost 20 years, and then was an advisor after. He eventually died in New Mexico. And so the New Mexico State House of Representatives in 2007 unanimously passed a resolution declaring that Pluto is a planet when it's in New Mexico skies. And they made March 13th, 2007, Pluto Planet Day. Clyde Tombaugh was from Illinois, and the Illinois Senate passed a similar resolution in 2009. They stated that Dr. Tombaugh is so far the only Illinoisian and only American to ever discover a planet, and they claimed that Pluto was unfairly downgraded to a dwarf planet. So what about New Horizons? New Horizons' mission has fundamentally changed. It is no longer going to the only unexplored planet in the solar system, but it is going to a planet. So a couple weeks after the decision, New Horizons is doing its gravity assist around Jupiter. So it takes these pictures as it swings around. On the left is, of course, Jupiter. You can see the great red spot. And 4 of Jupiter's moons, Io, Europa, Ganymede, and Callisto, were also photographed. But this is not a Jupiter talk. This is a Pluto talk. So I will fast forward a little bit to 2011 in June. Another moon is found. So this was found again by the Pluto Companion Search Team using the Hubble Space Telescope. They were taking these really long exposure photos in order to look for rings around Pluto, which would be quite faint. And they found this other moon here. It's very faint. It required 8-minute exposure, so that's why Pluto and Charon are kind of blocked out in the middle, because they would be quite overexposed in these photos. This was originally called S2011-134-341. You may notice a little bit of a difference between how this was originally named and how Nix and Hydra were originally named, where they had a P after the year. We can't use the P anymore. Pluto's not a planet. This is its minor planet designation, 134-340. They wanted to name it Cerberus after Pluto's 3-headed dog that guards the gates of the underworld, but that was taken, I believe, by an asteroid. So it was named an alternate spelling, Kerberos. A year later, they discovered Styx by a similar method. It was even darker than Kerberos, and this was originally called S2012-134-341, and then later named, much easier to say, Styx, after the goddess and river in the underworld in Greek mythology. So fast forwarding a little bit again, New Horizons is approaching Pluto's system, and it takes these pictures as it gets closer and closer to Pluto. In December of 2014, on the 6th, ground control here on Earth sent a message to New Horizons, who was hibernating for its long journey. Hey, wake up, it's time to do science. And about a day later, New Horizons responded, I'm awake, I'm ready to do science. And then the actual Pluto encounter began on January 15th of 2015. So before New Horizons gets too close to Pluto or any of its moons, it does a fail-safe dump of all the data it's taken, every picture it's taken, all of its spectra and stuff like that, in case something goes horribly wrong and we lose all of that. And in that fail-safe dump was this photo of Pluto, which is our first real detailed photo of Pluto. So you can see it's got lots of stuff going on. It's got these mountains on the left side. It has this kind of heart-shaped thing, which is actually sunken in. And this is a true color image. So if you were standing in space outside Pluto, this is pretty much what you would see. So now we get to name all these features. I can't go through them all, but all of these in green are named for people either related to Pluto in some way. Tombaugh, of course, discovering it. And then there's a Burney feature up here named after Venetia Burney, who suggested the name for Pluto. And then the others are cartographers and mountaineers, people with great achievements. And then these in red are all mythological names from various cultures that are all some way associated with the underworld or the dead. And then these last three are all named for other historic space missions, Voyager, Sputnik, and Hayabusa. So it's not just there to take pretty pictures. New Horizons was also there to do some science. So I'll touch on some of the objectives that it's had. Of course, to measure the temperature. So the temperatures on Pluto range between minus 378 degrees and minus 396 degrees Fahrenheit, which is quite chilly. For context, liquid nitrogen is only about minus 321 degrees Fahrenheit. The surface composition was also confirmed to be about 98% solid nitrogen, but there is also solid methane and carbon monoxide. Here on Earth, these are all gases, but because it's so cold, these are all solids and behave more like rock on Pluto. There are also mappings of where these volatiles are. So on the plot on the right, the pink is the methane, the yellow is the nitrogen, and the green is the carbon monoxide. So you can see all three of these really settle into that heart-shaped area. But on the other side of the planet, in this more mountainous region, we have a lot of water ice. So the mountains on Pluto are made of just H2O, which at these temperatures, again, behaves a little bit more like a rock. So it forms mountains. New Horizons also looked at Pluto's atmosphere. It is made almost entirely of molecular nitrogen, of N2. This is not too dissimilar from Earth. We also have a mostly nitrogen atmosphere, as do Titan and Triton, which are the largest moons of Saturn and Neptune. Sublimation is also a really interesting process that occurs on Pluto's surface. So on the day side of the planet, so the side facing the sun, the ice evaporates just like ice in your freezer slowly evaporates, and we call this sublimation because it's going from a solid to a gas, kind of skipping the liquid stage. Winds then move this sublimated ice across the planet, and it condenses and is deposited on the cold side of the planet, on the night side. So the winds move this ice around. New Horizons also took a look at Charon. They found it really has no atmosphere. Its surface is mostly water ice, mostly frozen H2O, as opposed to Pluto, that's mostly nitrogen. But there's also this red organic material that you can see on the North Pole. So this is material that was escaping gas from Pluto's atmosphere. Because Pluto is so small, it has a hard time holding on to its atmosphere, and some of it is escaping. And this material goes over to Charon and then settles where it's coldest at the North Pole. As you can see from this image, you can't see the South Pole from New Horizons pictures, but it's expected that there is another red spot on the South Pole for the same reason. New Horizons also looked at the other moons. It found they are quite bright for their size, which would imply that they are probably made of ice. Ice is very reflective, very bright. You can kind of see Charon is pictured here at the bottom, so it's much larger than the other four moons. And all four of these moons are spinning quite rapidly, and we don't quite know why yet. So on its way out of the system, New Horizons took this last photo of Pluto, lit from behind by the sun, and it moved further on into the Kuiper Belt to do more studies of other Kuiper Belt objects. And the next year, the USPS released Pluto Explored stamps honoring New Horizons and Pluto. So that's it for our talk. I want to plug Laith is going to put a poll up on our Instagram story so you can vote on whether you think Pluto should be a planet. As Amanda said, this is our last talk for the semester, but next semester will be in 2024, which is CoffeeShop Astro's 10-year anniversary. So look forward to some very excellent talks. Thank you so much. We are happy to take any questions. Oh, that's all you first. Mm-hmm.
Yeah. Yeah.
Yes.
It's mostly because Pluto and Charon are so close in mass, so they are
Could
essentially...
you repeat the question?
Oh, sorry, I'm going to repeat the question. Okay, so why is Pluto doing this little orbit around a center of mass where there's nothing there? It's just making this little circle. That's because Pluto and Charon are so close in size, so they're essentially just in their own binary relationship rather than like our Earth-Moon system where our moon is very small compared to us. So Pluto and Charon have a different sort of balance in their relationship, and it makes this special little orbit rather than what we typically know with our other moons. Yeah.
About this question, our moon has a mass of about 1/80th that
It's about half.
It's about half.
Yeah. Yeah.
So that's why it's much farther out.
Yeah.
Right.
Yeah.
You next.
You had that little chart that said that, if I get this, Pluto's albedo is, I mean, it's very bright.
Yes.
And although he said, if it's icy, it reflects, but everything out there would be icy, right? So is that really, is the albedo, if it's high, does that tell you about its composition?
Yeah, it essentially tells you about its composition in a way that so Venus, so like Venus has a really bright albedo because of its atmosphere. It's like mostly sulfur. It's basically, it's got diamonds in it. I mean, Venus has a really interesting atmosphere. We could do a talk on that later. But so Venus is really reflective of everything. And Pluto is icy, so it's also really reflective of stuff. So if you shine light on ice, it's a lot brighter than, whereas Mercury has like no atmosphere, its albedo is really low. It's just a rock, so it can't really reflect anything. That's why it has a really low albedo. So it tells you a little bit about what the planet's made of as well. Not exactly what it's made of, but could be having some sort of atmosphere. Yeah. Yeah.
Oh, Hayabusa. So the question is, when we showed the geography on Pluto, some of the names were after other space missions. Sputnik is the first successful space probe. Voyager is, there are two Voyagers. They have both left the solar system. And Hayabusa is the first trip that was able to bring a sample back from an asteroid. This is a Japanese space mission. Shashwat, did you have a question? Yes.
Question. Okay, so
Oh, it's back.
okay.
Okay. So, yes, Pluto has a hard time holding on to its atmosphere. It is losing its atmosphere. It was actually thought that it might not have one by the time New Horizons got out there, but it still does. But yeah, in a billion years, I don't think it'll have an atmosphere. Yes.
Yeah.
So, back in long ago, they had to have hour-long exposures to a telescope.
Yeah.
There's apparent movement there, and there wasn't any computer, so you have to be judging.
Yeah, so that's a really interesting question. He didn't because the stars really don't move at all between like when you look up in the sky tonight, you'll probably see the same exact stars tomorrow at the same time. They don't really move a lot. So between these hour-long exposures, the planet is also not moving very much. An hour is much less than the time scale of like days when they took the pictures or when he compared images. So that really wasn't a problem. He didn't really have to nudge the telescope. Now today, telescopes, if you wanted to take much longer exposures, they might sync it up to a camera and then it could. But no, he didn't have any computer. He didn't have any way of really. He just had to do it all himself, which is really impressive. Yeah.
Okay.
Yeah. Oh yeah. Can you go back to the
Yeah.
all the way back?
All the way back.
Sorry, we got a lot of slides. Reverse rejected. Oh, here we go. Okay, so can I have the laser pointer?
Yeah.
Yeah, so you might notice that there's some stuff like up here that just like appears out of nowhere, sort of. These are just artifacts, and the way that you could tell is also by comparing, like if he had this same image the next night or a couple nights later, he could compare them and see like that's just an artifact that appears one time between these two images. So he could take this image, compare it to a different night, and be like, oh, that's not there. That's not actually the planet moving. He had so many images to compare that he was able to identify what was an artifact of his camera or what was actually a planet moving back and forth. You can see this one has a really nice shape. Pluto, has the same shape between images. This has a weird elongated shape, and so does this one over here. So these things are all stars. There could be some artifacts in here just of the camera or the photographic plate that he had. I mean, even in astronomy today, we sometimes get artifacts, which is break pixels. So these are just artifacts of the photo plate. Yeah.
Yes, it is. So the question is the red deposits on Charon that are coming off of Pluto's atmosphere that you see on the top and probably on the bottom of Charon. These are organic material, which just means they have carbon in them. So there are methane and carbon monoxide on Pluto. Both are organic materials. But they just call that red material on Charon complex organic material because it's more complicated molecules than we necessarily can list off. Does that answer your question? Okay.
Question.
I'm just wondering, considering the blinking stuff, did Tombaugh also discover a few asteroids during this?
I believe he did. He kept working for the observatory for a long time after this, and I believe he did also discover more objects than just Pluto. From these particular images, I don't know exactly, but I'm sure that he saw some more objects. Yeah.
Of course, on the other hand, there probably would have been a different
Yes. Yeah. So like comets might have like weird tails or yeah. So right. Yeah. So I mean even just the difference between the two positions here, you could probably calculate how fast Pluto's going. So he knew what he was doing, which is crazy. Yeah. But I highly recommend getting to Arizona and visiting the Flagstaff Observatory. You can learn all about this and see these exact images. You can see the telescope. It's very cool. I don't work for them. I've been there and I really liked it. So I encourage you to go. Yeah. Any more questions?
Yeah, one more. Yeah.
We gotcha, yeah.
So that would be enough to keep Mercury afloat.
Yeah.
Because the mass of Mercury is 1/6 millionth the mass of the Sun. Mass of the Earth-Moon system about 329,000. Jupiter 1 in 1,047. So that's manifestly a planet. Saturn 1 over 3,400 million.
Yeah, it's pretty crazy. The IAU, they had the opportunity to grandfather in Pluto with the rest of the planets, and they just chose not to. So you could write a scathing letter yourself and send it to the IAU. All right, thank you so much, everybody, for coming. We really appreciate it.
Thank you.
We'll see you next semester.